Welcome back. We have been talking about air, and we have noticed that the active part of air is oxygen and is very important. Now, in the laboratory, oxygen can be prepared by various methods such as heating potassium manganate 7. When we were learning about permanent and temporary changes, we came across a process where we heat potassium manganate 7. Who can remind me the products? Well, let us check if you're right. Potassium manganate 7, when heated, gives potassium manganate 6, manganese 4 oxide, and oxygen gas. This is our interest, oxygen gas. So in this first method, we heat potassium manganate 7, which is usually purple in color, to give us a green-black solid mixture. Potassium manganate 6 is green, while manganese 4 oxide is black. But this time these ones are not of interest. We're interested in the oxygen gas that we have produced. Oxygen gas now can be collected using different methods. One method is over water method. Another one is known as syringe, or use of a syringe. We shall learn about this in a short while. We have just mentioned that oxygen can be collected using over water method or use of a gas syringe. Over water method employs the fact that oxygen is sparingly soluble in water, and therefore it can be collected using this setup. The next method that can be used is use of a gas syringe that does not require any special properties. However, if we need to measure the amount of oxygen gas produced, then use of a gas syringe would be the best. The second method of preparation of oxygen gas is heating of nitrates, such as sodium nitrate or potassium nitrate. When you heat sodium nitrate, it will decompose into sodium nitrite and oxygen gas. Sodium nitrate and oxygen gas. This is another example of a permanent chemical change. Again, in this case, oxygen is collected by over water method. The third method is heating potassium chlorate. Similar to the previous experiment, potassium chlorate decomposes to form potassium chloride and oxygen gas. Another permanent change, permanent chemical change. The gas again is collected by over water method that you can see in this picture. The fourth method is the reaction of sodium peroxide with water. Water is delivered through to the round bottom flask using a dropping funnel and it reacts with sodium peroxide to form oxygen and sodium hydroxide, as per this equation here. Finally, the fifth method is the decomposition of hydrogen peroxide using manganese 4 oxide catalyst. Now, a catalyst is a substance that alters the rate of a reaction. So, hydrogen peroxide is delivered through to the round bottom flask using a dropping funnel, where it meets the catalyst manganese 4 oxide that enhances the rate of decomposition of hydrogen peroxide into water and oxygen. Hydrogen peroxide decomposes to form water and oxygen gas, and the reaction is increased by use of a catalyst called manganese 4 oxide. Now, the catalyst does not take part in the chemical reaction, and hence it is written on the arrow that shows the direction of reaction. The first few bubbles of oxygen gas are not collected because this gas is mixed with air that was originally in the flask. Oxygen is a colorless gas and is slightly soluble in water, and that's why we can collect it by over water method. Another important fact to note is that oxygen relights a glowing splint, and that we had already mentioned when we were dealing with temporary and permanent changes.